So yeah, without further ado, we have our first workshop host, Laisha, who's representing Aleo today. She's also our Dev Rel ambassador at the foundation. And I hope one day soon is going to be a Dev Rel engineer for the foundation. So yeah, clap for her. So today's going to be around 10-15 minutes of understanding what Aleo is and what we can do with Aleo and what are the kind of applications we can build. And then we use rest of the time to actually build something. The format of the workshop is that we'll be building a basic program on Aleo, and then there will be a task for you to add something to it or fix something in it or just wait for the end. And with that, you have to submit it, deploy it on the chain, and then submit it in the form. The process is pretty simple, so we'll walk through that towards the end. So let's get started. A little bit about me. I am a Dev Rel ambassador at Aleo. Previously, I've been an ML engineer with Lucidity Finance. Been in the space for around 3 years. Have been dabbling with Dev and Dev Rel. And yeah, ZK is a space I'm really excited and passionate about. So for all of you who will be participating in the workshop, I would suggest that please set up the environment, which is Snap OS, Leo, and Rust. So you can go to this link. It has all the details on setting up the installation. If any of you already has this setup done, please make sure that you migrate to testnet beta, because that is where we will be deploying all of the programs on. Some of you might be familiar with the Aleo and have the testnet older version set up. So please migrate to the new one. It's pretty simple. You just have to switch the branches a little bit. I'll also show this link a little later. And let's get started. So I think zero knowledge proofs have been around. A lot of people are talking about it, and it's not a new concept. It's been around. It's just that now we have started implementing it in real world use cases and in the Web3 side. It's a cryptography concept where we're trying to prove something very simple. There are two parties. One is a verifier, one is a proof. I, as a prover, am trying to say that a particular statement is true, but I'm not telling you any details about what that statement is or anything which gives away what that statement is. And that's where the zero knowledge concept comes in. But what is the deal about it that it was not able to get implemented before, given that this technology exists in the cryptography side of things for so long now? The problem is, how do you make sure that the wrong words are not there? So essentially, you're saying, I know they know, but I don't know what they know. And how many of you here have played this game called Wordle, the New York Times? It's a very simple example of zero knowledge. You're just posting this one screenshot saying that I've completed the puzzle today, but nobody knows what the solution is. But this is simple. When you talk about real-world data and real-world applications, the statements that you will try to prove and verify are not going to be that simple. And that's where you need a sophisticated way to explain this computation. So in order for you to generate zero knowledge proofs, there are two major ways. You can either go the ZK Snark way, or you can go the Stark way. So these are two kinds of zero knowledge proofs. Aleo ecosystem is based upon ZK Snarks. Now what ZK Snark is, let us break it down. So the word Snark stands for succinct, non-interactive argument of knowledge. So that's a lot of words. Let's take it one by one. We know what zero knowledge is. Let's get it out of the way. What succinct means is that the proofs are small, fast to verify enough for what we are trying to do or what we are trying to prove. And then these are the non-interactive is the property that's unique to ZK Snark, is that we are working on a trust-based system. That means there is no interaction of information about the statement between your prover and verified. So it's a trust-based system, and again, that's also the reason why it's faster and the proofs can be smaller. And then argument is something, so there's a concept called soundness, which needs twofold, which means that the proof is complete. At any number of times, let's say I as a prover am trying to say that this statement is true and the verifier negates it, even though it is true. All of this computation, a million exchanges between prover and verifier, they should be completed in some finite time. It should not be an infinite computation. So that's a property that should always hold. But why was this relevant and why did we understand this? Because the concept of zero knowledge and the proofs which are generated in this ecosystem are slab. Now let's understand, why did we need an ecosystem like Aleo? let's go down the memory lane a little bit. We started with centralized systems like banks. Then we started to get digital, but the systems were again very centralized. We had digital gold, we had digital lockers for maintaining money, but the control was always centralized. And until the Bitcoin ecosystem came in, there was no way in which you could have decentralized way to transfer money. So Bitcoin introduced a new concept where there was some sort of security with how your money was handled. But again, when such public exchange of money was happening, everything was again susceptible to some sort of attack. So people wanted to come up with a way in which they take Bitcoin but add a layer of privacy to it. So that's the time when Zcash came into existence. But you could only move money. You couldn't do much with it, right? There's no logic attached to it. So you can just transfer money. So that is the time where Ethereum came in and they introduced the concept of a virtual machine on chip that led to the concept of smart contracts coming in, where you program some logic that controls how and when this money moves and where it goes and how it goes. And if you look at it, we wanted privacy, we came with Zcash. We wanted some control, we let privacy go. And that's exactly what Aleo does. It gives you the programmability, it also gives you the privacy all inherently in one ecosystem. So you don't need to go to different ecosystems to execute your transactions, to verify your transaction. It all happens in one ecosystem. And how Aleo operates is on the concept of zero-knowledge execution, which so it's based on a paper that was published by Zcash folks, and a lot of the concepts in Aleo are also derived from what work was done in the Zcash space. What zero-knowledge execution here means, I'll talk about it a little more when we proceed further, is that a lot of your computation, be it heavy holding of your logics, your computation and your business logic, can happen off-chain. We'll understand why and how we can do that. But this is essentially what I just said, but conveyed in a 2D format, is when we started with Bitcoin, we had Zcash. The trade-offs were that when we had privacy, we did have programmability. When we added programmability, we had to let privacy go. And Aleo fills in that right gap. But why Aleo as an ecosystem should be your choice if you are looking to build private applications. So Aleo, as you all know, is an L1. It's a native L1 which lets you build private applications with everything, right from your computation to your verification to deployment and everything on that same ecosystem. So let's understand how is all of this possible, what are the tools you have as developers and as ecosystem supporters so that you can get started with building on Aleo. So the first thing that differentiates this ecosystem is zero gas fees. And I'm not saying zero gas fees for everything, it's for private transaction. Now what private transactions mean here is that any computation that you're doing off-chain, right? You do not need to pay any gas for that. So this means, let's say you're building an identity solution and you're trying to verify the identity, let's say through some model, and you're doing some identification computation, you don't need to pay fees for that. Only when there is an on-chain state of date, that is the gas fees you'll incur, which is considerably less if you look at other ecosystems where your provers, whatever work they are doing and through generation, all of that incurs a lot of gas fees. Another thing here that this off-chain computation enables is unlimited application runtime. So technically you can have really long or really heavy, say, machine learning programs that can run indefinitely without you having to wait for certain operation to happen on-chain or have a dependency on this on-chain computation to end to be able to do something. Now, why all of this matters? If you look at the example, you look at certain applications. So ZKML is one of the applications which is gaining a lot of popularity because ML as a space suffers from data integrity issues and validation issues. And ML ecosystems are not that, I would say it's not that simple. They're complex, there's a lot of data involved. And in cases where you're dealing with heavier models like deep learning models, you need good runtimes without having to wait for or look at heavy gas fees on chain. So in those applications or in those cases, Aleo as an ecosystem would give you the edge. And a lot of you would be thinking, I don't know how to write circuits. I don't know how to probably convert my business logic to a zero-knowledge circuit. How do I go about it? that's when, just give me 1 minute, I'll come to that. But there's also one more point I want to highlight. If you look at your traditional blockchains, as the number of executions you are doing, your cost is linearly going to increase. Because more the complex your instructions are, the more opcodes you're going to utilize, and then the gas will keep compounding. In Aleo, this cost will flatline because, again, the computation is not always on-chain. And let's say you're doing a very heavy computation, a lot of it is going to happen off-chain, and only the verification of the proof is going to happen on-chain. So that linearity in increase of the cost is no longer there. So you, as developers, have the control to optimize a lot of it without having to just deal with opcodes optimization on-chain. Now let's come to resources. How does the Aleo ecosystem operate, and what all does it have for you as either developers, or if you're looking to become a validator or a prover? Now, in traditional blockchains, you can either get started as a developer, or you can run your own node and become a validator. So you can still do that in Aleo, but there's also a concept of prover. So what that means is that whenever you're doing all of this computation off-chain, you're essentially generating a zero-knowledge proof, right? That gets verified on-chain. So that is the job of the prover, to generate that proof for you. Now, if you have good enough hardware, you can do that yourself. But if you do not have the necessary hardware requirements, you can also give it to a third-party person to generate it for you. You can do it on AWS. And everything in the Aleo ecosystem operates on Aleo credits. So we'll come to the details of that. But let's go back to what all do you have. So it's a ground-up system. Given that it's private and permissionless, there's everything for everyone. So you have your Snack OS, which operates on proof of succinct work, which means that if you have done enough work to generate the proof, you get rewarded. And that reward is done in Aleo credit. And that's what the provers are going to utilize. Then we have a native VM. And this is not ZK EVM. It's separate. It's its own native VM, which is called the Snack VM, which is what the validators they utilize. And then comes Leo. So Leo is a Rust-based DSL, so domain-specific language, that has been created so that writing those programs that can understand these proofs makes it a lot more easier. So we don't have the concept of smart contracts, we have the concept of programs, and it's called Leo programs. We look at how it operates and what all Leo as a language can provide you. So to give you a little bit of concept of how the ecosystem looks like for Aleo, we talked about the infrastructure layer as to what we have and what powers it. From the perspective of you to build production-ready applications, we had SDK, we had Explorer, and there are quite a lot of applications. I've not mentioned a lot of them. ZFast is just one of them. There's Puzzle Wallet. There are different applications in the ecosystem that are out there that you can try. We'll also be trying one of them today. But the idea is that you have every resource that you would need to build an end-to-end application, all without having to worry about how to write the proof, how to optimize for proof generation, because Aleo takes care of that for you. So, and now let's look at, we know how Solidity as a language operates. Because EVM is generally the first ecosystem that you get introduced to. With Leo, what it does is that it bridges the gap between zero knowledge and the concepts that you are trying to implement by making it a tad bit more simpler for you. So let's say I'm trying to prove that I know the sum of two numbers, A plus B is C. And I don't want to reveal that. Obviously, my sum is private. So what I'm going to do is first I'm going to generate a proof that says that I know the sum of these two numbers. Now, what the job of Leo is that I'll walk you through a detailed flow of information, but just to give you the crux of it, what Leo does is that whatever proof you've generated, it compiles it into Aleo instructions. Now, these Aleo instructions are essentially similar to the, you could say, like you have opcodes, Aleo instructions then get compiled into certain opcodes. So this is the intermediate step where the provers come in, they generate the proof for you. Then that gets converted to your Aleo instructions, and that then goes to your machine level code and then gets evaluated. Now, The only difference in the ecosystem compared to other ecosystems that you would have seen is the prover coming in. So once you've generated the proof, the handling of the program is done by the validators who come to a consensus, which is proof of stake. And then once they've come to the consensus, your program gets added. The provers actually work on a different consensus, which is proof of succinct work, because that's how the reward operates for provers. Now, I said something about the Aleo ecosystem deriving a lot of the things from the Zcash ecosystem, right? So, how many of you here know about account model? Can I get a raise of hands, maybe? So, account model is what the Ethereum ecosystem operates on. So, there's a global state. So, anytime you need to know, say, the balance or anything with respect to your account, you can just get it. Whereas there's another model called UTXO. How many of you are aware of UTXO? UTXO is what Bitcoin was based on, stands for unspent transaction output. Very similar to how you use cash. You give a $500 bill and you want to pay $350, you get $150 back, but you have to give $500 to the person. So that's what unspent transaction output operates on. So Aleo also has a transaction model, which is, it introduces a concept of record. Now, how it's different is that a record, it's obviously derived or holds inspiration from UTXO. What a record does is that in UTXO, you can only hold information of account and just the balance. In record, first you can pretty much have any sort of metadata, any information that you want to capture. So it's basically a new struct that is introduced. And again, there are other concepts in Aleo why the record model is powerful. So in Aleo, there's a concept of transitions instead of just functions. So what happens is that a transition can, multiple transitions make up a transactions. So you can have, say, 7, 8 different computations, and then you can have one final transaction that takes into consideration all these transitions, does some work, gets you the final output. And a transition can consume these records, one or more of such records. So that's how the ecosystem operates. Let me give you an example of how you as a developer will start with writing your Leo program and how that Leo program propagates in the ecosystem, where the prover comes in, where the validator comes in. So let's say there's a transaction which you've deployed and that goes into the system. So what happens? So in a regular setup, your transaction goes to the validators come to the consensus. You'll see that there's something called as program registry that's written here. So in Aleo, there's a program registry which manages all the programs. So every program that you write has to be unique by its name. The job of this part is to make sure that whatever proof that would have been generated when the transaction was deployed is verified. The consensus is done, and then it's getting deployed. What happens between this step, right? Before I'm sending my transaction to the validator, what did I do? So taking a step back, in order for me to take my Aleo program and generate a proof for it, and for now going to assume that I'm the prover and generating the proof for my set. So my job is take my Aleo program, then generate a proof of it, which means transpile it into certain Aleo instructions. And then those instructions are compiled into opcodes, which on the basis of which your gas computation or whatever Aleo credits you would need for deployment gets computed in this step. And this execution response is then sent to my validator. So once I've done this step, I essentially go to this flow, which is what the regular flow you are aware of, a standard POS flow. So if you are a developer who's writing an application, so when you're sending an execution response, the first person receiving it is the prover. And then the regular execution response can go back to the front end. This is a very simple comparison between the ecosystems which are there. So we have miners and validators, developers, and then there are roll-ups. In Aleo has reimagined the way the decentralized ecosystem operates, given that we are looking at privacy privacy is something which is inbuilt. We're not trying to add privacy to an existing ecosystem, but building with privacy from ground up. So that's where the two words complete the ecosystem in complete sense. And for all of you looking to understand what kind of use cases, are being built on Aleo, or what are the kind of things you can build, we have around, let's say 300 plus Aleo ambassadors across the globe. And we have around, I think, over 40 projects which are there. And then these are across different categories. There are projects in gaming, there are projects in decentralized identity, tooling and infrastructure projects. We would see a lot of projects around ZFi, because DeFi is, again, an ecosystem where a lot of privacy is important and is appreciated, especially DEXs and any kind of exchanges or leverage strategy building platforms. So these are some of the ideas that people are building on. You can also connect with any of the folks from Aleo after the talk to understand how you can get started. And we'll also talk about a grant program that we have at the end. So now that we've talked enough about Aleo and how it operates, let's start coding something and let's start building something. How many of you here don't have the setup done? So if you don't have the setup done, you can still run the programs. There's a playground on which you